Today let us discuss about the Woodward Fischer rule, that is basically for calculating the wavelength, that is the lambda max value. Now there are certain rules for finding this lambda max value. Let us see that. First of all, you have to see the parent value. Now in parent value you will be seeing whether your given organic compound is open chain or it is closed chain. If it is open chain, you will be giving value 217 nanometer. So parent value will be 217 nanometer. If it is closed chain, then you have to see whether your compound is homoannular or heteroannular. Now in this case, we are calculating lambda max value for the dienes. So in case of homoannular diene, homoannular diene means when both the double bonds they are present in the same ring. So you will be giving the value 253 nanometer. In case of heteroannular diene, you will be giving the value 214 or 215 nanometer. Heteroannular, hetero means different, annular means ring. So when two double bonds they are present in different rings, that is known as heteroannular diene. Since we are calculating it for dienes, dienes means those compounds which are having two double bonds. So such compounds will be dienes. Besides the parent value, you have to write certain increments. That is, first increment is regarding the ring residue, for which you will be giving value 5 nanometer. For alkyl substituent you will be giving value 5 nanometer. For exocyclic it will be 5 nanometer, and for double bond extending conjugation it will be 30 nanometers. Now let us see one by one what does it means. So let us see what is ring residue. For ring residue, first you will be selecting the main parent chain for the diene. For example, double, single, double. This is the main parent chain, and you will be seeing CC bonds. So they are attached to how many single bonds. So that you have to see. So for ring residue, you will be seeing C double bond C carbon. It is attached to how many single bonds, and those single bonds should not be common. So let us calculate for this. So we will see the C double bond C carbon. So this carbon it is attached to one single bond here. This carbon it is attached to two single bonds, but only this will be considered for the ring residue because this is common. This carbon it is attached to this single bond, but it is common, so it is not ring residue. This carbon it is attached to this single bond. So total there will be 3 ring residues. Now let us come to alkyl substituent. Again for alkyl substituent you have to see C double bond C carbon. It is attached to whether it is attached to alkyl group. So this line it is telling you about the alkyl group. If this line it is present here over, you won't consider it as alkyl substituent because here the carbon is C single bond C carbon and we require C double bond C carbon. Next let us go to exocyclic. Exocyclic means again if it is a diene system, that is double, single, double system. So one double bond it will be present outside the ring. So it is present outside the ring, but it should be attached to one of the carbon of the ring. So such compounds having such bonds, they are exocyclic. For example, in this compound with respect to B, this double bond it is present outside B and it is part of this conjugation system. So this is exocyclic. Now with respect to A, we cannot say this is exocyclic because it is not attached to this carbon. Then is double bond extending conjugation. Now in dienes, as you know, 2 double bonds should be present. So apart from those 2 double bond, if there is any extra double bond, it will be extending conjugation. So you will be adding 30 for that. So in this case, there are 3 double bonds. So one double bond is additional. So one conjugation is extended here. So you will be adding 30. Let us try to solve this example. For example, in this case, we will write down the parent value, ring residue, alkyl substituent, double bond extending conjugation and exocyclic. So parent value, it is a cyclic compound, and it is if you see it is if you remove this double bond, it is heteroannular, and if you remove this double bond, it is homoannular. So this compound is homo as well as hetero. So we will be writing the higher value, that is 253. So parent value here will be 253. Now let us talk about the ring residue. So ring residue means CC double bond. You have to see it is attached to how many single bonds. So this is the first ring residue. This we will not consider ring residue, it is common. If you see this carbon, this will be the ring residue. This is not a ring residue, it is a common. So here if you see, now this carbon you will see, this will be the ring residue. This we are taking as alkyl substituent. So total you can see there are three ring residues. So for 1 it is 5, for 3 it will be 15. One alkyl substituent is there, so 5. Double bond extending conjugation. So in dienes, as I told you, there are 2 double bonds. So here one additional double bond is present. So for additional double bond you will be writing 30. Then exocyclic. So first with respect to this ring, if you see, there is no double bond which is outside this ring and attached to one of the carbon of the ring. With respect to this ring, this double bond, it is outside this ring and it is attached to one of the carbon of this ring. So one exocyclic double bond is there. So if you calculate this, it will be 308. So lambda max will be 308 nanometers. So this is how we calculate the lambda max value according to the Woodward Fischer rule. Let us do one more example. Let us do this example. Now in this case, again the parent value, it will be 253 as since it is homohetero both. Ring residue, again you have to see CC double bond, it is attached to how many single bonds. So one is this, 2, 3, 4. 4 ring residues are there. So 4 5s you will be writing 20. Now look for exocyclic. With respect to A, there is no exocyclic double bond. With respect to B, if you see, this is exocyclic, and with respect to C, this is exocyclic. So 2 exocyclics are there. So you will be adding 10. Then double bond extending conjugation. Alkyl substituent is not there, so you will be adding 0. Double bond extending conjugation. So in dienes 2 double bonds are there. So 2 double bonds, they are additional. So you will be adding 60. So when you add all of them, you will be getting 343 nanometers. So this will be the lambda max value. So this is how lambda max value it is calculated for the dienes.